Okay, Mr. Officer, we are solving logarithm and exponential equations today. And so we're going to solve to 3 decimal places, and we're going to check with Desmos. So when I have this here, I have several approaches I could do, but I know I have to lower the exponent, so I'm going to use logarithms. In order to do it, I'm going to go log base 5 of 9.2 is equal to x. So I'm just rewriting it using logarithms. If I want to find out what that is, I know I can just go math, go back to my log base, it's 5, 9.2, and so I have x is equal to a lost value, 1.37, 1.379 to 3 decimal places. When I look at this one here, I'm going to solve, so before I go on, this is the exact value, this is the approximate value. But because I wanted 3 decimal places, I needed to get this good approximation. Alright, sorry, moving on. I need to solve for x. Well, in order to do it, I have to isolate this particular scenario here. I have to get that all by itself. Similar to when I had 2x plus 1 equals 7, I'd have to get 2x by itself. Here I need to get the x by itself. So in order to do that, I am going to subtract 1 from both sides. So it's 5 to 1/2 to the x. Subtracting 1 gives me 6.3. And then I'm going to divide both sides by 5. And so it's 1/2 to the x is equal to 6.3 over 5. Now I need to get rid of my x, and so I'm going to, as opposed to this one, I just rewrote it. I can rewrite this one as well, but I'm going to try the other approach by applying a logarithm by both sides. It ends up being the same thing. It's just conceptually just a different conceptual approach. I know those cancel, and so this is what x is equal to. And so then if I take this and I throw it into my calculator, math up to log base, I'm going to know this is 0.5, just convert it in my head, and this is 6.3 divided by 5. It will do this calculation all on its own. I don't even have to type it in, and I get negative 0.333. So I know x is equal to negative 0.333. Okay, moving on. This particular equation, now my exponent's on the bottom now. In order to get rid of it from the bottom, I have to multiply both sides by the common denominator, which is 1 plus 2 to the x. 1 plus 2 to the x. And so when I do that, I get 5 plus 5 times 2 to the x. Do not make that 10 to the x. Is equal to, those cancel, is equal to 8. Subtracting the 5, I get 3. Dividing by 5, I get 3/5. So now if I rewrite this or apply logarithm on both sides, I get x is equal to log base 2 to the 3/5. And I'm going to do this one on Desmos just for fun. I know this is y is equal to 5 and y equals 8 divided by 1 plus 2 to the power x. And we can see that I get a negative 737. So x is equal to negative 0.737. And there is my answer for this logarithm. So that was exponential equations. Now I want to solve logarithmic equations. And there's really 2 different kinds of logarithmic equations. One kind of equation happens when you get a log of something equals to a log of something else, where these bases are the same. Well, if this is A and this is B, in order for them to be equal, A has to equal B. I just know that A is the same as B. That's what this scenario is. I know these 2 logs are equal, the same base, And so that, therefore, x squared must equal 3x plus 4. Solving this, I bring everything to one side, make it equal to 0, and I factor. I get x minus 4 and x plus 1. So the x is 4 or the x is minus 1. Now, one of the things I have to check though, I have to make sure my answers work. If I put negative 1 in there, that's negative 3 plus 4. That is a positive value, that's okay. And that is also positive. If I put 4 in there, I get a positive, and it is all good. So I have two answers in this case. I keep them both. Trying another type. The other kind of logarithm equation I have is if I have log of some base of an x of some kind equal to some kind of a number. Well, when I do this, often the easiest thing is to just rewrite in exponential form. So 5 to the 3. Well, I know this is 125 is equal to x minus 2. So x will be 127 is the exact value of that. And I believe this is the last one coming. Now, this one now I have a logarithm equal to a number. So in order to solve this, I need to make it into a single logarithm equal to a number. And so I use my logarithm properties, and adding means I'm going to multiply x times x minus 2 equal to 3. And so now I'm going to change forms 2 to the power 3 is equal to x, and then multiply this out, x squared minus 2x. This is 8, so it's x squared minus 2x. Whoop, minus 8 is 0. So what two numbers multiply to get negative 8? Add to get negative 2. Well, that's going to be negative 4 and a plus 2. So x then is 4 and x is negative 2. If I take these values and I look up here, if I take this negative 2 and I plug it in here, I get a negative value. Also in there, I also get a negative value. That is impossible. I cannot get a negative logarithm. If I check 4, that's okay. That's okay. And so that is my only answer. So, good luck.